This is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about our definition and terminology. In definition and terminology, our first module is random variables. So, context. Definition and terminology, question bank of random variables. That is our first module. So, in our first module, our topics are based on random variables. So, before going to start definition and terminology definitions, first of all, how many topics are there, we will discuss. In random variables, we have two types of random variables are there. So, first one is discrete and the second one is continuous. So, random variables are two types. First one is discrete random variable and second one is continuous random variable. So, coming to the next topic, probability distribution. The probability distributions are two types. First one is the discrete probability distribution, that is nothing but probability mass function, and second one is continuous probability distribution, that is nothing but probability density function, PMF and PDF. Okay, so and the last topic is mathematical expectation. Last topic is mathematical expectation. So now we will discuss about our definitions and terminology of module 1, random variables. Okay, so our first question is definition of probability. Consider any random experiment. So state the definition of probability. State the definition of probability. So consider any random experiment. The total number of events are small n. Out of them, m events are favorable to a particular event E. Therefore, the probability of an event E equal to favorable events divided by total number of events. So, consider the random experiment. So, that is, let us consider up to n. So, here the total number of events are n. So, in this, we have favorable events m. The favorable events m. So, according to our probability definition, probability of an event equal to favorable events divided by total number of events. So here the favorable events are denoted with m and the total number of events are denoted with n. So therefore the probability of an event E equal to m divided by n. So next, coming to the next question, what is random experiment? What is random experiment? An experiment whose results cannot be predicted in advance. So what is random experiment? The definition of random experiment is an experiment whose results cannot be predicted in advance, or the results are not predicted. If the results are not predicted, then we can say that is random experiment, or the result is not unique. If the result is not unique, then we can say that is a random experiment. Next question is, describe the sample space. Describe the sample space. So what is the definition of sample space? The collection of all possible outcomes in any random experiment. The collection of all possible outcomes in any random experiment is called sample space, or the total number of outcomes. The total number of outcomes is called as sample space. Okay. So the total number of outcomes in any random experiment is called sample space, and the sample space is denoted with S. Sample space is denoted with S. Okay. So for example, for tossing a coin. So this is our random experiment because here we have more than one result. So if we have more than one result, then we can say that that is random experiment. So tossing a coin is random experiment. In this random experiment, we will get head, tail. If I toss a coin, we will get head, tail. So this is our sample space. The total number of events or the total number of outcomes. The total number of outcomes in any random experiment is called sample space. It is denoted with S, or the collection of all possible outcomes in any random experiment is called sample space. So next, coming to the next question, narrate a continuous random variable. Here, narrate the discrete random variable. Discrete random variable. A random variable is said to be discrete. A random variable is said to be discrete if the range of random variable is finite. If the range of random variable is finite. Or a random variable is said to be discrete random variable if the range of random variable is either finite or countably infinite. Finite or countably infinite. Next question. So now coming to the next question, narrate the continuous random variable. Narrate the continuous random variable. This is our next question. So what is the definition of continuous random variable? A random variable is said to be continuous. A random variable is said to be continuous if the range of random variable is interval of two real numbers. Interval of two real numbers. So coming to this definition, discrete random variable. So discrete random variable is said to be the discrete random variable is said to be here the range of random variable is finite. Then we can say that that is a discrete random variable. Okay, so in the above example, so tossing a coin. So this is our example, right? So in this, the sample space consists of how many elements? Head, tail. So here I am considering the event equal to getting a head. Getting a head. So therefore x equal to here we have only one head is there. Here we have 0 heads. That means 0, 1. So this is example for discrete random variable. Here the range of random variable is finite. Here the range of random variable is finite. So now coming to the next definition, narrate the continuous random variable. So a random variable is said to be continuous if the range of random variable is interval of two real numbers. For example, if the number of students in a classroom or the number of students heights of the students, or we can say that the heights of the students in a class maybe 4 feet to 6 feet. So let us consider x equal to 4, 6. Let us consider x equal to 4, 6. So this is the example for continuous random variable. So what is the definition of continuous random variable? A random variable is said to be continuous if the range of random variable is interval of two real numbers. So that is called as continuous random variable. Next, coming to the next definition, state the definition of probability distribution. So what is probability distribution? Let x is a discrete random variable. Then P of x equal to x is said to be probability distribution or probability function. If x is a discrete random variable, then P of x equal to x is said to be probability distribution or probability function. Or if x is a continuous random variable, then also f of x is said to be probability distribution or probability function. So next, coming to the next question, what is a probability mass function? Or what is the definition of probability mass function? So a function P P is mapping from x of s to real numbers. P is mapping from x of s to real numbers is said to be a probability mass function where capital X is a discrete random variable. Capital X is a discrete random variable. If it satisfies the two conditions, first one is P of x greater than or equal to 0 and second one is the total probability is equal to 1 or summation P of x equal to 1. The total probability is equal to 1. So, this is our probability mass function. Or we can say that if x is a discrete random variable, then the function f of x is said to be probability mass function, and if it satisfies the following conditions, first one is f of x greater than or equal to 0, or that is nothing but p of x greater than or equal to 0, or we can write p of xi greater than or equal to 0. That is our first condition. And second condition is summation p of x equal to 1 or summation I equal to 1 to n p of xi equal to 1, or we can write summation f of x equal to 1. So, this is called as probability mass function. Next, what is probability density function? So, what is the definition of probability density function? A function f is mapping from x of s to real numbers. A function f is mapping from x of s to real numbers is said to be probability density function, where x is continuous random variable, if it satisfies the following conditions. First one is f of x greater than or equal to 0. Second one is the total probability is equal to 1. Okay. So, otherwise we can use one more definition is there for this. What is probability density function? Let x is a continuous random variable, then the function f of x is said to be probability density function if it satisfies the following conditions. So, first one is f of x greater than or equal to 0 and second condition is the total probability is equal to 1. That is nothing but in continuous we can write integration over minus infinity to infinity f of x dx equal to 1. So, this is our second property of probability density function. Next, coming to the next question, state the definition of expectation of discrete random variable. If x is a discrete random variable associated with PMF, probability mass function P of x, then its expectation is given by expectation of x equal to summation x into P of x. Summation x into P of x. So, or we can write summation expectation of x square equal to summation x square into P of x. And similarly, summation x cube, expectation of x cube equal to summation x cube P of x. So, like that up to so on, we can write expectation of x power n can be written as summation x power n into P of x. So, this is the definition of expectation of discrete random variable. So, next coming to the next definition, state discrete random variable. State discrete random variable. A random variable is said to be discrete. A random variable is said to be discrete if the range of random variable is finite. If the range of random variable is finite. So, for example, so if we toss 2 coins or tossing 2 coins, this is our random experiment, right? So, in this random experiment, the sample space consists of how many elements? 4 elements. So, what are they? Head, tail, tail, tail. So, we are having 4 possibilities. Those are head, tail, tail. Okay, so this is our sample space. So, then coming to the discrete random variable. So, here let us consider event E equal to getting number of heads. So, here how many heads are there? two heads are there. Here we have one head, here we have one head, here we don't have heads. That's why the 0 heads. So therefore, x equal to, we can write 0, 1, 2. So if we toss 2 points, we will get 0, 1, 2. Okay, so this is finite, right? So therefore, we can say that this is discrete random variable. So a random variable is said to be discrete if the range of random variable is finite. Next, coming to the next definition. State the definition of probability distribution. If x is a random variable, then probability of x equal to x, or probability of a random variable, we can say that probability distribution. So our probabilities for the random variables is known as probability distribution or probability function. Or if x is a random variable, whether it is discrete or continuous, then f of x is said to be probability distribution or probability function. And also we can say that f of x is nothing but p of x equal to x. Okay, so this is our probability distribution or probability function. So now coming to the next definition, state the definition of variance of a discrete random variable. Variance of a discrete random variable. If x is a discrete random variable associated with a probability mass function p of x, then its variance is given by variance of x equal to e of x square minus e of x whole square. E of x square minus e of x whole square. So that means expectation of x square minus expectation of x whole square. Next definition. State the definition of expectation of a continuous random variable. Expectation of a continuous random variable. So in discrete, we have to use summation. In continuous, we have to use integration. Okay, so let us discuss about continuous expectation of a continuous random variable. So the definition is here. If x is a continuous random variable associated with a probability PDF is nothing but probability density function f of x, then its expectation is given by e of x equal to integration over x into f of x dx, or we can write integration over minus infinity to infinity x into f of x dx. So this is the expectation of continuous random variable. And the last definition is state the definition of variance of a discrete random variable. So one more definition is there. If x is a continuous random variable, so then so this is associated with, this is the variance of a continuous random variable. State the definition of variance of continuous random variable. If x is a continuous random variable associated with the probability density function f of x, then its variance is given by variance of x equal to e of x square minus e of x whole square. So and also we can write e of x is nothing but in continuous integration over minus infinity to infinity x into f of x. But e of x square is here integration over minus infinity to infinity x square f of x dx. F of x dx. Okay. So, but in discrete, so let us discuss about discrete. So, expectation of x in discrete random variable is summation x into f of x or p of x equal to x. We can write p of x equal to x, or we can write x f of x also. And the expectation of x square is summation x square into f of x or p of x equal to x. So, this is our module 1 definitions and terminology. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.